Hi everyone, and welcome back to yet another lesson in Python programming. In today's lesson, we're going to have our first introduction with a Python library called NumPy, which is quite useful when working with computational data. Now, with that said, let's have a look at the objectives for today's lesson. Now, the objectives for today's lesson is as follows. First, we'll discuss the NumPy library. Next, we'll move on to exploring the applications of the NumPy library. And finally, we'll have a practical demonstration. Now, let's begin by briefly discussing the NumPy library. In a nutshell, NumPy is a Python library which is widely used for numerical computing. It provides support for large multi-dimensional arrays, matrices, as well as a wide range of mathematical operations that can be performed on these data structures. NumPy is known for its speed and efficiency, making it a popular choice for data scientists, engineers, and researchers who need to work with large datasets and complex computations. Additionally, NumPy is often used in conjunction with other Python libraries such as Pandas, Matplotlib, and scikit-learn to create powerful data analysis and machine learning pipelines. Consider this data cube from our previous lesson. If you recall, we are able to slice across various dimensions. In this example, we could slice across the products dimension, geography, as well as the time dimension of our data. The goal of NumPy is to make this process a lot easier, and that is what makes it such a powerful tool. Earlier on, we mentioned that NumPy is quite useful, especially when we integrate it with existing Python libraries. Let's take a look at a couple of these libraries. First, there is Pandas, which provides data manipulation and analysis tools, including data structures for handling tabular data and time series. Matplotlib is yet another popular library used for data visualization, providing a range of charts, plots, as well as graphs. Scikit-learn is yet another popular Python library, which provides machine learning algorithms for tasks such as classification, regression, as well as clustering. And lastly, TensorFlow, which is a popular library for building and training neural networks and deep learning models. These libraries work together seamlessly, providing a powerful ecosystem for data analysis and scientific computing in Python. Now, as we've gathered, NumPy has a wide range of applications in scientific computing, such as numerical and scientific computing. NumPy is used for a variety of numerical and scientific computing tasks, including linear algebra, Fourier analysis, signal processing, and optimization. NumPy can also be used for data analysis, often in conjunction with Pandas to manipulate and analyze large datasets. To add to this, NumPy can also be used for machine learning applications. NumPy is used in many machine learning frameworks, including TensorFlow and PyTorch. It provides a foundation for building and training neural networks and deep learning models, as we've previously mentioned. And lastly, it can also be used for image and video processing, especially when analyzing large arrays of pixel values. Wonderful. Now, once again, it's time to get our hands dirty with a bit of code, and we'll start playing around with the NumPy library. So without further ado, let's dive right in. Now, to get started with the NumPy library, we first have to install the library through our command line tool. So I'm simply going to type cmd, and then over here, I'll do pip install NumPy. Now, I do have this installed already, so I should have some sort of notification or alert that lets me know that the requirement has already been satisfied, and that is because NumPy has already been installed on my machine. In your case, if you've not yet installed NumPy, go ahead and run the command line. Excellent. So, now that NumPy is installed, I simply have to do import NumPy at the top over here as np. So I've imported the library and I've converted it as np. So going forward, I'll use np to reference the NumPy package. Great. So to get started, I'm going to show you exactly how powerful this tool is. So consider the payload variable that we had in our previous lesson, the three-dimensional array that we had. I'm going to set this equal to np.array. And I'm going to open up a couple of parentheses over here. And I'm going to paste in that array from our previous lesson, the three-dimensional array that we worked with previously. And simply at the bottom over here, I'll just call the print statement, and I'll call payload 3.ndim for number of dimensions. And if I run this code now, this should output 3. So now we can actually verify that the array that we created in a previous lesson was indeed a three-dimensional array. And we can do that simply just with NumPy and a couple of properties and methods and functions available to us inside of the NumPy library. Excellent. So what else can we do with NumPy? I'm going to erase this code over here, and I'm going to create an array from scratch using just one line of code. So I'll create a variable called a over here, set this equal to np, and I'll call the arrange function over here, and that is arranged with a single r, and then I'll pass in the number 6 over here. So next I want to go ahead and print this out. So I'll say print a, and I'll run my code now, and notice that I have an array with 6 indexes from 0 to 5. And that's how simple it is to create an array with just NumPy. What I can also do is I can reshape this array. If you take a look at the output, this is a 1D array. What if I wanted to transform this array into a 2D array? Well, I can simply create a new variable called b. I'll set this equal to a, which is the array we created at the top. And then I'll call .reshape on this array, and I'll pass in the parameter 2 and 3. And this will shape my array from a 1D array into a 2D array, where in my 2D array, I'll have 2 separate arrays with 3 different values. Great. So what I'll do is I'll simply just print b over here. And if I run this now, notice that I've gone from this flat 1D array to a 2D array with the values 0, 1, 2, and 3, 4, 5, respectively. Excellent. Now notice that when I use the arrange function over here, I managed to create a 1D array with 6 indexes from 0 to 5. But what if I wanted to include a specific range of values when I create my array? Well, I can simply do the following. I'll start from scratch over here, and I'll create a new variable over here. I'll set this equal to np dot arrange once again, and I need to provide a start value and a stop value. And keep in mind over here that the stop value is not included. This is exclusive of the array. So I'll pass in 1 as well as 15 over here, and then I'll simply just print out this array. And if I run this now, notice that I have an array from 1 up until 14, where 15 is excluded from my array, which is the stop value. I could take this a step further. Let's actually change the values over here. So I'll pass in 10 as the first parameter. That's my start value. I'll pass in 50 as the stop parameter, the upper limit. And then I'll pass in an optional parameter, which is going to be 5. And what will happen now is I will increase my values in my array from 10 with a step of 5 between each value. So if I print this now, notice that I've gone from 10, 15, 20, 25, 30, 35, 40, and 45, where 50 once again is excluded. And that's how simple it is to use NumPy to create arrays with step values. So what about creating an array with random values? Is that even possible in NumPy? Well, the simple answer is yes. I'll erase all of this code. I'll create a variable called a. I'll set this equal to np.random, and then I'll call the rand function over here, and then I'll pass in the value 7. Then I want to print this out, so I'll say print a, and if I run this now, notice that I have 7 different values inside of my array. And if I run this again, we have a different set of values. It's highly, highly unlikely that you'll probably ever get the same values if you had to click the run button within a span of, let's say, 1 minute. Can we achieve a similar outcome by turning this into a 2D array? Well, again, the answer is yes. I'll simply change the parameters over here. I'll set the first parameter equal to 2 and then 4. And this will now provide me with a 2D array. So if I run this code now, notice that I have 2 arrays within my existing array. Also notice that I've got 4 values within each of them. So I've got 4 values that I've generated inside of a 2D array. Excellent. Let's do 2 more examples. And for the next 2 examples, we are going to perform some basic mathematical computations. So I'll erase the code once again. I'll create a variable called a, and I'll set this equal to np dot array, because we do want to provide a new array over here. And the first value will be 2, the second value will be 4, 6, and lastly 8. Let's clear this up a little. And what I want to achieve with this array is I simply want to sum up the values inside of this array. So on a new line, I'll create a variable called b. And I'll set this equal to np.sum, which is the sum function. And I'll sum the values inside of this array. Now I can simply go ahead and print b. If I run my code, I have the sum of all the values inside of my array. Now let's try something different, and let's try to calculate the average of a 2D array. So once again, I'll erase all of this. I'll create a variable called arr for array. I'll set this equal to np.array, where I will provide a basic array. So I'll open a square brace over here, and inside of the square brace, I'm going to open another set of square braces, and the first value I'm going to pass in is 4. And then 5, and then outside of this array, I'm going to create another array. So I'll open up my square braces, and then I'll say 3, and then we can opt for 7 as well. So we want to achieve the average, or we want to obtain the average of the values of these two arrays. So to do that, I'll simply create a variable called avg for average, set this equal to np.average, which is a function, and I'm going to pass in the array that I created at the top over here. And then I'm simply going to call print the average, or avg. And now if I run this code, notice that I have 4.75, which is the average of the values of this 2D array over here. And that is it for today's lesson. Throughout this lesson, we learned exactly what NumPy is, what the library is used for, its applications. We also performed a practical demonstration with just a few lines of code, and then we also learned how to perform computational tasks on those arrays. In our next lesson, we're going to work with yet another Python library called matplotlib. And with this library, we'll be able to visualize our data. So for all of that and more, I'll see you in the next lesson. Cheers.